Assalamu alaikum. My name is محسن المحسن. In this video, inshallah, I'm gonna explain how to answer question 7. Okay, and this question, he asks a moment applied to a beam of the cross section should determine the centroid position and centroidal moments of inertia with respect to an horizontal axis that passes through the centroid of the composite section and the maximum tensile and compressive stresses of the beam. Okay, so I'm gonna draw over here. Okay. Here's 200 millimeter, 25 millimeter. From here to here is 150 millimeter. Here's the same as the top one, 25 millimeter. To here also 25 millimeter, and here 100 millimeter. Okay, now we need to find the centroid of this one. Where is the centroid over here? So we need this one number 1, this one number 2, and this one number 3. Okay, we need to do schedule here for the area, here's for the y bar, and here y bar area. Okay, we will start with number 1. Okay, the area of number 1 is the base multiplied by the height. So the base is 200 and the height is 25. So 200 multiplied by 25 is 5000. Okay, now we need to find the y bar for the first one. Okay, to find the y bar is the center of the first one enter the ground. So the half of the first one is the half of a 25. So 25 divided by 2 is 12.5 millimeter. Okay. And the whole height is the 200 millimeter. 150 plus 25 plus 25, you get 200. So to find the y bar for the first one is to minus the 200 with the 12.5 to get this one. So it will be 200 minus 12.5, so 187.5. So it will be 187.5. Because y bar is the center, the distance, like for distance between the center of the first one until the ground. This one, the y bar one. So when I said the maximum height of this one is 200, at the top here, between the center here until the center is 12.5. Here at the top 12.5 and the down is 12.5. So we're gonna say 200 minus and the top here 12.5 to get the y1. Okay, now here is the 187.5 multiplied by 5000. You will get 937,500. The same as the second one. The base, as you see here, the base as you see here is a 25. So 25 multiplied by the height of the second one. The height of the second one is 150. From here to here, 150. You will get 3750. So the same as the y bar. The center of the second one is from the ground is 100 millimeter. Is 100 millimeter. The center of the second one to the ground is 100 millimeter. Why? Because as you see here, 200 is the max, is the whole height. So the half of the 200 is the center of the second one, so is 100. Now the same here is 100 multiplied by 3750. You will get 375,000. The same as the third one. The center of the third one to the ground. Now the height of the third one is 25. And the center, its mean is the same as the first one, is 12.5. But I cannot say 200 minus 12.5 because the center is near to the ground, so is only 12.5. 12.5. Here is the base 100 times the height is 25. You'll get 2500. 12.5 multiplied by 2500. You will get 31250. Now to find the center for the whole thing, you will add the area, the whole area, 5000 plus 3750 plus 2500. You will get 11,250. And the same as y bar multiplied by the area, plus you will get 1343750. So the y bar for the whole is the y bar area over the area. So 1343750 over 11250. You will get 119.4 millimeter. Okay. So the center for the hole is 119.4 millimeter. Okay. Okay. Now we need to find the moment of inertia. We need to find the I. We're gonna draw again. Okay. Like we said, from here to here is 200 millimeter. For the first center enter the ground is 187.5 millimeter. For the second center to the ground is 100 millimeter. The center of the third one to the ground is 12.5 millimeter. The whole center to the ground is 119.4 millimeter. Okay. Now there is a rule to find the moment inertia. I equal I bar plus area multiplied by the distance square. So it's mean that I1 plus A1 times D1 square plus I2 plus A2 multiplied by D2 square plus I3 plus A3 D3 square. So as we know, the I is 1 over 12 multiplied by the base multiplied by the height cube. Okay. Now 1 over 12 multiply for the base of the first one is 200. You can take from the schedule from here. 200 multiply by the 25 cube plus the area that we get from the first one, 5000, multiply by the distance. Now for the distance, we need to find the distance between the center for the first one and the center of the whole one, the whole thing. We need to find this one, the center of the first one, and enter the center of the whole thing. Now, as we said, the center between the first center enter the ground is 187.5, and the center of the hole into the ground is 119.4. So when you want to find this one over here, when you want to find the distance between them, is you said 187.5 minus 119.4 to get the distance between them. So 187.5 minus 119.4 square plus, now for the second one, 1 over 12. The base for the second one is 25 multiplied by 150 cube plus the area is 3750 multiplied the same idea, the distance between of the second center to the whole center. Now this one 100 is the second distance between the center of the second to the ground, and 119.4 is the center of the hole to the ground. Now you need the distance between them of the two centers. So 119.4 minus 100, you will get this one. You can say 100 minus 119, no problem, because of the square you will cancel the negative. So you can do both. So 119.4 minus 100 square plus, for the third one, 1 over 12 for the base is 100 multiplied by the 25 cube plus the area is 2500 multiplied by the distance. Now the distance between the center of the third to the center of the whole thing, the distance between them is 12.5 minus 119.4, or 119.4 minus 12.5 to get the distance over here. Now you can say 119.4 minus 12.5 square. So you will get 6059027.8 millimeter power 4. So to change it to meter, it will be 6059097.8 times 10 minus 3 all to power 4, because millimeter power 4. So you need to change it 6059097.8 times 10 power minus 12. When you put in the calculator this one, then you said equal, you will get 6.06 times 10 power minus 5 meter power 4. This one the moment inertia. Okay, now we have found the moment of inertia. Now we need to get the stress of the tension and the stress of the compression. Now let's start for the stress for the tension. Moments multiply for the center, the radius tension, over the moment of inertia. We already have the moment, and we already found the moment of inertia. So we need the center of the tension. Now as you see here, I will draw it again down. This is the moment. So here it's getting tension, and here compression. So in this drawing is getting here tension and here compression. I will draw it again. Here is the compression, here is the tension. Now this is the center of the whole thing. This one is the 119.4 millimeter. So for the center of the tension is this, the 119.4 millimeter. Why? Because the center of the whole thing to the maximum tension is 119.4 millimeter. So we put here, we have a moment 15 times 10 power 3. We change it 15 kilonewton multiplied by the meter to 15 Newton meter, multiply by the 119.4 times 10 minus 3 over the moment inertia that we get is 6.06 times 10 power minus 5. You will get 29. Okay, let's erase this one. You will get 29.55445545 here point. Okay, this is not professional, this one Pascal. We needed for the stress we needed mega Pascal unit. So this is 1, 2, 3, 4, 5, 6. So you'll get 29.56 megapascal. Now for the compression over I. We have the moment, we have the moment of inertia. Now we want the center of the compression, the center of the whole thing to the maximum compression. We need to get. So as you remember that we have the 200 for the whole height, 200 millimeter. So you want this one. So you will say for this one 200 minus 119.4. You will get the distance between the center of the whole thing to the maximum compression. You will get 80.6 millimeter. So 15 times 10 power 3 multiplied by 80.6 times 10 power minus 3 over 6.06 times 10 minus 5. You will get a 19.94 megapascal. You can put here minus That's okay. But the minus here does not mean that the value is negative. No, the minus refers to the compression. So you can put minus, you cannot put you can put minus, and also no need for minus. That's okay. But the value it will be 19.994 megapascal. You can put C or compression. So I hope this video is useful to you, and I hope you understand from my explanation, and thank you for listening.